Hey, what's up, everybody? So we've been really working hard on these quadratics, finding the vertex, now solving them. So what you now understand is that when you are solving a quadratic equation, you are finding the x-intercepts, and that's where that parabola crosses the x-axis. We also know from the previous videos in practice that you have three scenarios: one where there's two x-intercepts, one where there's one x-intercept, and one where there's no x-intercepts, which simply means that's where the graph just doesn't cross the x-axis. And in the previous slide, you sketched a few. So today, now we're going to look at some algebraic methods to solving a quadratic. So here we go. Ax squared plus bx plus c equals, on pause, I'd like you to pause for a second to take a guess what number goes there. Hopefully you guessed it's set to equal 0. Why is it set to equal 0? Because it's where that parabola crosses the x-axis, where y does not have a value. So the question is, how do we solve it? So there's a couple of different forms of a quadratic equation that you need to be familiar with. The first form that we're going to discuss is what's called factored form. Factored form is simply the product of linear factors. So any linear factor multiplied together, okay, that's considered factored form. And again, see how it's set to equal 0. So the question is, all right, how do we solve it? So we're going to do what's called the zero product property. So it says here, if a times b equals 0, then a equals 0 or b equals 0. So if you use a little common sense, if you take anything and multiply it and the product is 0, that means one of those numbers has to be 0, or both of them has to be 0, because anything times 0 is going to be 0. So simply what you're going to do is you're going to take each linear factor and you're going to set them to equal 0 as two separate pieces. So we have x plus a equals 0 and x plus b equals 0. And then to get the answers, you would simply solve each little equation. And the good news here is that they're basic one or two step equations. So let's take a look at a couple examples where we apply this zero product property. First one over here. So this is a pair of linear factors. How do we know they're linear, by the way? Because if you look at this leading coefficient, or this variable here, okay, it's to the first power. That makes it a linear expression. So if we're going to use a zero product property, we're going to take each of these and we're going to set them both to equal 0. So x plus 2 equals 0 and x minus 3 equals 0. Now, if you look, we just have two little equations to solve. Here, you subtract 2 to both sides, x equals -2, or add 3 to both sides, and then you have x equals 3. And that's your answer. So in this case, this quadratic equation has two x-intercepts. All right, this one over here, the only difference here is that this expression has a little bit more work to it, but it's the same process. So we're going to take this guy and set him to equal 0, and I'm going to take this guy and set him to equal 0. And then you solve it like a basic equation. -2 minus 2, 3x equals -2, divide by 3, x equals -2/3. I mean, if you have -0.666 repeated, that's okay, but typically, if you remember, we prefer to have fraction answers. Here, you're going to add 7 to both sides, and you have x equals 7. So again, you're looking for two solutions here. This last one here can sometimes be tricky for students because they forget about this. This is a linear factor. This is not just a number. Because it has an x attached to it, it's considered a linear factor. So you're going to follow the same protocol here. So you're going to set each linear factor to equal 0 and then solve it. Here, 3 times what equals 0? If you divide both sides by 3, okay, this is a perfectly legal move. 0 divided by 3 is just simply x equals 0. That's a solution. And then here, you subtract 4 on both sides, and you have x equals -4. So the two solutions here are x equals 0 and x equals -4. Okay, so now I'm going to have you practice on a U-draw on the next couple of slides. Thank you.